Chapter 3, Exercise 32. Part A, show that R is symmetric if and only if R inverse is a subset of R. And Part B, show that R is transitive if and only if R composed with R is a subset of R. Right, so we have two new words that we haven't seen before, so let me define them properly. Now we have... Oh, actually that's not what I wanted to do. I wanted to say what transitive and symmetric mean. Not in that order. So symmetric and transitive. Right, so a relation R is symmetric if X R Y is true implies that Y R X is also true. So you can swap the elements of the ordered pairs around in the relation, and then you still get that they must be in the relation. And then transitive means that if X R Y is true and Y R Z is true, then it must be the case that X R Z is also true. So basically you kind of link from here to here, and then from here you also link to here. That's the idea behind transitive and symmetric relationships. Okay, so let's go ahead and show these. For our part A, we're going to assume that R is symmetric. That is, this holds. And now let's suppose, since we're trying to show that R inverse is a subset of R, let's suppose that Y R inverse X is true, or, if you will, that Y comma X is an element of R inverse. These two are the same statement. Then it must be the case that X R Y is true by definition of R inverse. R inverse. That is X R Y if and only if Y R inverse X. Okay. Now, given that R is symmetric, YRX must also be true. So Y comma X is an R, meaning that YX being an R inverse implies that YX is an R. In other words, R inverse is a subset of R. Okay, and now I think I didn't actually add this annotation. No, I didn't. But that is one way of the if and only if. Now we're going to go ahead and show the other way. So let's assume R inverse is a subset of R. And now let's suppose, that X R Y or X comma Y is an element of R. We're trying to show that if X R Y is true, then Y R X is also true. Then Y R inverse X must be true as well. And then since R inverse is a subset of R. Y comma X being an R inverse implies that Y comma X is an R meaning that Y R X is true. Oh, ran out of space. Let me add a couple pages. There we go. Right, so we have this so far. And in other words, R is symmetric. That is two M's. Alright, there we go. Alright. And now, we have to show that what R is transitive if and only if R composed with R is a subset of R. So let's do, whoops, not this way. Let's do this. Let's assume that R is transitive. And now we want to show that R composed R is a subset of R. So let's suppose, what do you want to do? Let's do X comma Z is an R composed R. Then by definition, there must exist some Y such that X comma Y is an R and Y comma Z is an R as well. So X comma Y is an R, or rather, let's just write in the other notation, X R Y is true and Y R Z is true. And then by transitivity of R, which we just assumed, X R Z must also be true. Fantastic. And thus, XZ being an R composed R implies that XZ is an R, and thus R composed R is a subset of R, as expected. And now we go ahead and prove the other direction. Let's assume that R composed R is a subset of R. And let's suppose X RY is true and Y RZ is also true. So this is our initial assumption. We're assuming this. Assuming that, we have to show that X RZ is also true. Then there exists some Y such that, well, X RY and Y RZ, in other words, there exists some Y such that X comma Y is an R and Y comma Z is also an R. So X comma Z must be in R composed R. And now since R composed R is a subset of R by assumption, then XZ being an R composed R implies directly that XZ is an R as well. Right, so x, y in R and y, z in R, both of these together imply that x, z is an R. So R must be a transitive relation. And there we go. That's all of exercise 32. I just moved and finally settled in my new place, and it is quite a bit noisier than the last place I was in. So do expect some background noise. I don't know if you can hear it, but it might be present, and I apologize, but there is literally nothing I can do about it. So we'll all just have to live with it. Anywho, I hope this was helpful, and I will see you in the next video. Bye-bye.